The 757 has a single outflow valve for regulating cabin altitude. Control of the outflow valve is automatic or manual. In automatic, two identical but independent controllers are provided to control outflow valve position. The controllers are programmed to maintain a scheduled cabin altitude for every airplane altitude. One controller is selected, and the other is armed to take over should the selected controller fail. The pressurization system automatically conducts a self-test of the armed controller during landing. In manual, standby DC power is used to position the outflow valve. Negative pressure relief valves located forward of the cargo doors prevent outside air pressure from exceeding cabin pressure. Positive pressure relief valves in the aft fuselage relieve differential pressure. The cabin altitude controls and indicators are located on the overhead panel. Now we'll discuss normal operation. Cabin pressurization is controlled with a 3-position mode selector. Selecting either Auto 1 or Auto 2 provides automatic cabin altitude control. A landing altitude selector is used to set the landing elevation, which is displayed in the landing altitude window. The selected elevation can range from 14,000 feet above sea level to 1,000 feet below. Normally, the landing elevation is set prior to takeoff. An auto rate selector establishes the desired limit for the cabin rate of change. An index mark limits the cabin rate of climb to 500 feet per minute and the descent to 300 feet per minute. Rate limits can be decreased or increased by changing the position of the auto rate control. During a normal climb or descent, the actual cabin rate of change is usually less than the limit established at the index. The pressurization indicators include cabin differential, cabin altitude, and cabin rate of change. The climb mode for the cabin is established after takeoff. The cabin differential pressure indicator displays the difference in pounds per square inch between the cabin altitude and the aircraft altitude. As the cabin climbs, the differential pressure increases until the maximum normal pressure of 8.6 psi is reached. The cabin then follows a climb schedule based on the 8.6 psi differential until reaching flight altitude. If the aircraft altitude remains constant for 1 minute, the cabin enters the cruise mode. At that time, the cabin controller compares the selected landing altitude with the scheduled cabin altitude, and then selects the highest for the actual cabin altitude. After the cabin is established at cruise altitude, flight altitude variations of up to 500 feet will not cause cabin altitude changes. However, a climb of more than 500 feet causes the cabin controller to re-enter the climb mode. Conversely, a descent of more than 500 feet puts the cabin into the descent mode. In the descent mode, the cabin follows a descent schedule until the landing altitude is reached. During descent, the cabin maintains landing altitude while decreasing differential pressure. The pressurization system does not have memory for takeoff airport elevation. Therefore, if a return to the takeoff airport is necessary, landing altitude must be reset to the departure airport elevation. The cabin is slightly pressurized at landing to prevent pressure bumps. After landing, the outflow valve opens to depressurize the aircraft. Let's now discuss abnormal operation. Should the selected autocontroller fail, power automatically transfers to the armed controller. The cabin altitude auto-inop light illuminates if both controllers fail. The failure is also indicated by a caution alert and the associated ICAS message. With the failure of both Auto 1 and Auto 2, the outflow valve remains in its last controlled position. Setting the mode selector to manual establishes manual cabin control. A manual switch can then be used to position the outflow valve, as shown by the valve position indicator. Both controllers have failed, and the auto-inop light is illuminated. Click on the appropriate switch to regain control of the cabin altitude. Touch the appropriate switch to position the outflow valve. Two cabin altitude lights will illuminate if the cabin altitude exceeds 10,000 feet. The lights will be accompanied by a warning alert and the associated ICAS message. The warning lights will not extinguish until the cabin altitude descends below 8,500 feet. During automatic operation, if the cabin climbs to 11,000 feet, a signal is sent to the AC motor to close the outflow valve. Automatic control is resumed after the cabin altitude descends. When the captain climbs to 11,000 feet during manual operation, a signal is sent to the DC motor to close the outflow valve. Manual control can be resumed when the cabin descends below 11,000 feet.